The doctor orders 1 liter of lactated ringers to infuse at 75 drops per minute. The drip factor is 15 drops per ml. How many mLs per hour will it infuse at? So what this problem is asking for is milliliters per hour. And we have drops per ml. So, and the doctor ordered it in drips per minute, which would be great if we were setting up a manual drip and counting with our watch. But we need to know, looks like we're putting it into a pump and figuring out what we're going to set the mLs at. What we're going to set the infusion pump at. So, I set up my proportion always with half here, and that equals what we need to know. And these are just 2 ratios that are set to equal. And it's 3 numbers and an x, and you cross multiply and divide. It's a simple proportion. So what we have is what comes from the pharmacy, what's written on the package. This is some sort of absolute information. It looks like the only thing that they gave us here is what's written on our tubing package, and that's 15 drops per ml. So what we need to know is how many mLs is in this 75 drops. Because if we know that 15 drops is going to fall per ml, if we figure out how many mLs this 75 drops is, we know how fast this is going to drop. 75 drops is going to go down in 1 minute. That's what the doctor wants. So we can convert this to an hour. We can go from minute to hour real quick just by timesing this by 60. And if you times this by 60 to turn it into a minute, you have to also times the 75 by 60 to keep them equal to each other, because it's a ratio. So that'll turn out to be 4,500 drops in an hour. So now we still just need to know how many mLs is in this 4,500 drops, because if we figure that out, then we'll know how many milliliters per hour, because if this is per hour, if the 4,500 drops is per hour, then however many mLs that is will also be per hour. So I'm going to go ahead and start plugging info in. And we're going to do our halve, right? We've got 15 drops will fall in 1 ml. And we need to know, right, how many mLs 4,500 drops is. So I'm going to put my X here because I want to solve for the milliliters. And we'll remember that this drops was per hour. So this also will be per hour, because what you do to one part of the ratio, you also have to do to the other. And a proportion is set up so that the drops, the numerators equal each other, and the denominators also equal each other. So we're going to cross multiply. We're going to go 4,500 times 1. And we get 4,500. And then we're going to divide by whichever number is hooked up to our X. That will always be your denominator, the number that you divide by. And we're going to end on 300 milliliters, because we solved for X. X equals 300. So if X, these are set to equal, across. So we've got our milliliters here. And we know, too, that this is per hour. So we've got 300 milliliters per hour. And now if you liked my formula from the previous solving for drops per minute, you'll know that we can double check our answer right now. And we can plug our, let's see, we'll refresh our memory here of what this formula is. We've got drops per minute is equal to volume over time times the drip factor. So if we plug this in, the V and the T is our milliliters per hour. So we do 300 over 60. And we times that by our drip factor, which is up here in the problem, which is 15. And now we can solve for drops per minute. And let's see, 300 times 15 is 4,500, which I'm feeling good about that because we've got 4,500 up here, what we solved for. And we're going to divide that by 60. And we're going to end up with 75 drops per minute, which is what we started with right here in the beginning of the problem. So I know that 300 milliliters per hour is the correct answer.